Good morning, everybody. Thanks so much for joining our webinar today. We are so excited to talk to you about machine learning in the energy sector. And we've got a couple of great speakers today for you. Chris Burns, who is one of our partner solution architects with AWS, is going to speak first. And then I'm excited to introduce to you Alex Tai from Pariveda Solutions. He is a machine learning lead and a principal based in Houston, and he's worked with a bunch of retail energy companies who are implementing machine learning technologies. And so he's going to share some of those learnings with you, and hopefully it'll help you as you either get started or progress on your machine learning journey. So Chris, I'm going to turn it over to you first. Chris is going to give us a little bit of a recap on AWS announcements at reInvent. Chris?
Great, thank you very much, Sue, and let me echo her thank you to the audience for attending today. So real quickly, I'm going to talk super fast here. This is not meant to convert you into a data scientist in 3 minutes. It's really meant to just give you a recap of the services that we've launched at reInvent this year and freshened our ML service stack. That's going to become relevant later on when you get into the actual good part of the presentation, and Alex is speaking. So without further ado, let me get into the recap. So actually, there was 13 announcements this year. I'm going to cover 11. 2 of them we're going to save for later. The first one was the Elastic Compute Cloud, the GPU instance. We got a new P3, and this thing is a fire breather. 8 NVIDIA V100 GPUs, 32 gig of GPU memory, 96 Intel Xeon processors. So why did we do this with 100 gigabit networking? If some frameworks, take for instance TensorFlow, originally out of the box, was very difficult to spread over multiple computers. So if we can pack more GPUs onto a single, we'll call it a single bus for the sake of brevity, then we get more training capacity in a single unit of EC2 instances. So multiply that over a distributed environment with our new optimized TensorFlow framework, and you're going to get gains of around 90% efficiency across 256 GPUs. And what that means by percent efficiency is when you add another machine to your TensorFlow training, it's not 100% gain in training capacity. There's a drop off there. You get a little bit of a vanishing gradient, if you will. So anyways, with these new instances and this new optimized TensorFlow framework, you're going to get about 90% efficiency across that stack. We also now have Elastic Inference, which is a fantastic add. It was requested multiple times by our customers. And what this does, when SageMaker deploys a model for inference, it doesn't use the GPU in the fashion that we would want to use in cloud computing. We want to saturate that GPU. We want to get our cost, our dollar per hour maximized. So what Elastic Inference does, it allows you to use a low cost instance, excuse me, my voice is breaking up here, use a low cost instance, but then add GPU elastically. So you can spin it up and use as much or as little GPU as you want, and you're going to get a huge cost savings versus just using a GPU instance and only inferring at whatever intervals your process is running. We have SageMaker Ground Truth, another huge add, if I could use that word, huge. So what this is going to do is going to make it easier for you to build your data sets. Anybody that's coming to machine learning relatively new in the last couple of years, you may have seen that all of these tutorials, all these training sessions, all of these articles and blogs, they always start with this pristine data set, and you just go about your learnings and everything's happy. Then you get into production and you realize you got to put your own data set together, and the wheels fall off. Ground Truth is going to make it easier for you to build your data sets. It uses a combination of Mechanical Turk or third-party vendors or your own employees to annotate a few images or text. It doesn't have to be images. And then our machine learning services take over, and we can automatically apply those labels to a majority of the data set. Still going to have a little human in the loop training there for the initial labels, and then to clean up afterwards, because this is not yet 100% accurate, but still a major step forward in helping you prepare your data sets. We now have a marketplace for machine learning, and what that is, it sounds exactly like it's written. It's a marketplace for algorithms and completed models that you can just plug into your business processes. There are free models out there. There are a couple of models that you would pay for as a premium service, because those models are very well trained on elusive, expensive data sets, but you can plug that into your processes just right there from the marketplace. We have SageMaker Reinforcement Learning, which on a personal note was music to my ears. Reinforcement learning has been a passion of mine for a number of years. And if you're not familiar with reinforcement learning, I don't want to steal too much thunder now. This is just a quick recap, but it's a form of learning that you may not be familiar with. It's not supervised training or unsupervised training. It uses exploration and exploitation to train a agent to make the best decision. We can also integrate that with AWS RoboMaker. So if you have an environment, a computer automated design or a CAM, computer aided manufacturing environment, you can now use RoboMaker to use simulations. You can use SageMaker reinforcement learning to train your agents in those simulations and then deploy them. That really represents a tremendous opportunity to reduce costs, to do prototyping, and also we're going to push further into manufacturing sector in terms of machine learning on AWS, which is another topic that Alex is going to address today. We have SageMaker Neo. Neo is another fantastic feature. I keep putting these superlatives in front of these services like they're not cool. But Neo is going to let you train a model once and then deploy it anywhere. Anywhere is a little up in the air right now. You see here where we support out of the box. So GPU, CPU, Xilinx is the FPGA. You have Cadence and ARM processors, and then also many different frameworks. Now the key here, we say anywhere because we're going to open source this project. And so if you have an obscure platform that you're using, maybe a legacy platform that is difficult to upgrade, you can use this open source project to still use SageMaker to train your models and deploy to the platform of your choice. New managed services, we have Textract. So think of Textract as a successor to OCR. OCR, as we all may or may not be aware, is very fragile in the sense that it can read one type of text and maybe not another type of text. If spacing differs, italicization can sometimes mess up OCR. So Textract is an advanced form of neural net-based OCR. I'll call it that just for the sake of explaining today. And I really recommend you go try that out so that you can get into the preview and see what that's possible to incorporate OCR into your applications now. So we have Comprehend Medical. If you know anything about Comprehend, it's topic modeling, it's sentiment analysis. And what it does is it works on a knowledge base. And the knowledge base is taken from, well, we'll say the English language here. Now, this is Comprehend Medical. The problem with the previous version of Comprehend is if you have clinical terms, these medical terminologies are not everyday vernacular that Comprehend could see. So I want you to think of the concept of a bag of words, perhaps. And what Comprehend Medical does is we've retrained Comprehend to use medical terminology, all those words and medicines that we can't pronounce, and it recognizes those. It also recognizes what's important here is disease conditions, which is really a new entity. It's a new state of being. So it can recognize topics, it can recognize an object, entities as people, but now it can also recognize a condition, which is actually a big deal. And I do apologize. I'm not giving these services justice by zipping through here like this. Amazon Forecast. So just as it sounds, we're taking a page from our deep AR algo, and we're going to turn into a service for you, time series forecasting. Also, we have Amazon Personalize. This is a real-time managed recommendation and personalization service. So recommendation engines and personalization can be difficult. So I recommend when you have an opportunity to give that service a look, these are managed services. You simply provide data. We provide all the training resources on the back end. So that's taken care of for you. And you simply feed data in and you get your results back out. So that's my bit. Thank you very much for being patient and listening to this spiel. I want to go very, very quickly and announce Alex Tai from Pariveda. Pariveda is one of our ML competency partners on the SI side of the house. I love working with Pariveda. I used to work with them when I was just a geo-based SA before I was a specialist. So I can say that and not make it sound like it's lip service. So Alex, with that, I'm going to wrap up and hand the baton to you.
Thanks, Chris. Thanks for the quick intro, Sue and Chris, and thank you everyone on the phone for joining. I know it's the end of the year, the holidays are fast approaching. So really my main goal today is to just really share our experiences in the retail energy space and really start the conversation. And hopefully, as I mentioned, as the next year is fast approaching, hopefully some of these stories that I'm about to share will be relevant for your plans for next year. And this is really just the beginning. Please, I'm sure that Sue and Chris will share our contact information afterwards. So please feel free to reach out to me for any additional details or clarifications, or really talking about how some of these experiences will be relevant and helpful for your journey ahead. So with that said, quickly about us. So Pariveda overview. Like Chris mentioned, we are an AWS Premier Consulting Partner with AWS. We are one of 4 U.S. partners with the machine learning, data analytics, and DevOps competencies in the U.S. And really, we have data and machine learning experience across nearly all industries. So like I mentioned, if you're not in the energy space, please do feel free to reach out to us. I'm sure I can point you to one of our experts that have worked with ML in whatever aspect. And then lastly, like I mentioned, talk to us after about any offerings or workshops that we have. This is really just the beginning, the start of a conversation around how machine learning has helped the energy sector. And a little bit about me. I'm a principal and machine learning lead in Houston. Being in Houston, I've worked with several retail energy providers here in the area, mainly around BI and helping them think through how to use and leverage their existing data as an asset. So obviously machine learning and the AI space plays very nicely into that. And as recently as last year, I published a point of view around how to effectively leverage predictive analytics and quickly deliver value to your enterprise. So I'll cover a little bit of that in the tail end of my presentation today. And then I think I mentioned this, I've spent the last 9 years with Pariveda and in Houston. So the retail energy sector is near and dear to my heart. Very quickly, just for a background of the machine learning impact from a study from Forrester back in 2016, they predicted that AI-driven companies will take $1.2 trillion from competitors annually by 2020. Just to put that in perspective, 1.2 trillion is obviously a very large number. It's larger than most GDPs countries in the world. And then on a separate study, Gartner, as recently as April 2018, came up with the same number, actually. 1.2 trillion will be derived by using AI technologies just in 2018 alone. So really, what all that's really saying is, if you don't start thinking about, or if you don't start effectively leveraging AI-driven technologies or solutions, you may end up on the wrong side of that 1.2 trillion and really miss out on the opportunities that really lies ahead. And just very quickly, we've already seen and heard a lot of success stories of AI in the energy and utility space. I think as an industry that relies so heavily on forecasting, machine learning has always, I think, relied heavily on using that as a use case, just simply predicting our customers' usage in the future, since so much of our business depends on it, right? Whether you're hedging, buying, selling, that forecasted number is key to the business. And I think AI has already seen, as an early adopter, has seen a lot of benefit and value already in the renewable management space specifically. So the story there was GE used AI to enhance their wind turbine efficiencies, which raised the power output by 5% while reducing the maintenance cost by 20%. So just some quick gains just by using the technology. And I think a lot of success stories around demand management as well, and I'll go into a story a little bit about how we've played in the demand response field later on. But Google was able to reduce their cooling demand by 40% by leveraging AI. And then lastly, for infrastructure management, think more about Internet of Things, how to smartly and efficiently manage power use by our smart devices. So for infrastructure management, an AI-controlled gas turbine combustion unit was able to reduce nitrogen oxide levels by 20% by smartly managing the operation runtime. With that said, let's jump into some of my experiences with leveraging machine learning with some of our retail energy providers here in Houston. So just a kind of a generic backdrop. Many of them approached us, I think starting maybe 2-3 years ago. They said, Alex, we're looking to leverage machine learning. We want to get in front of this thing, right, by 2020. Mainly, we want to think about how can we increase profits and really getting a competitive advantage because it is a commodity business. It's difficult to differentiate and make your offering stand out when most customers in the retail energy space don't think about their retail energy provider other than I have to pay a monthly bill to keep the lights on and keep my computer running. So machine learning has been a great tool to help retail energy providers think about how to gain that competitive edge. And the way we've tackled this ask, how to increase profits, obviously there's a myriad of ways to work on this, but three main areas that I've helped companies think and work on this question is, let's focus on the three main areas, maybe thinking about from a customer journey, from smart acquisition. How do we get better at not only increasing the volume of our customer base, but using machine learning to find good customers? Because in this business, it's not just about the numbers game of having more customers. Having negative margin customers can actually be very costly to your portfolio, mainly because if they fall out of the specific profile or shape that you're targeting or your main portfolio is serving, it's going to cost you a lot more to serve customers that have a varying or unexpected usage profile. Second, thinking about how do we improve retention. So if we have a good base of customers, how do we keep them happy? How do we keep them around? And the key to that is really understanding your customer. Working in the retail energy space, we have access to and we deal with a lot of granular and minute data. We get in Texas, we have smart meters and we get usage data at the 15-minute interval, and some meters already, customers have been installing devices that even give more real-time access. So AWS and big data phenomenon has really helped speed up this adoption of working with big data. And what I'm trying to say is retail energy has tons of it. And lastly, if we understand our customers, then we want to get into the space of real value add, and the value propositions here are huge, meaning how do we diversify our products more than and elevate our services more than just selling electricity to our consumers. So first is thinking about how do we get smarter with our pricing strategy? How do we optimize and really make sure that we're customizing our products not only beneficial for us, but beneficial for the customer as well? And then further on, if you think about new products and strategies, how do we enhance or even cross-sell some of our services that revolve around just providing electricity to our customers? And you can think of things like predictive maintenance. How do we elevate our offering to a smart home offering? So we're thinking about, hey, your AC might be running inefficiently. We can send an AC air conditioner repair technician out to your home before it actually breaks down to keep a consistent quality for our customers without them having to lift a finger. So with that said, let's jump into really the first example that I want to talk about. So this one focuses under the smart acquisition. How do we identify good customers? And like I said earlier, the key here was we have traditional strategies and ways to get more customers, but we want to use machine learning to target good customers. We want positive margin customers, obviously, and the first step to doing that is identifying what makes a customer positive or negative margin. So the way we handle that was, first, we enriched our customer data set with related attributes. We pulled in property data about our customers, like their square footage of their home, how many rooms, really even radiance data about how much sunlight was hitting their roof, because we were also interested in solar panel offerings as well. So really just thinking about how to really add more data about our customers so we can build a more comprehensive profile of them so we can understand them better. And then afterwards, we built a machine learning model to start segmenting our customers into discrete profiles. And the key here was to understanding what types of customers do we have. And as we built this machine learning model and through our iterations, we discovered a number of key significant variables. Some of the interesting finds are actually that the number of windows and the number of bathrooms and even the price of their mortgage was a significant attribute in determining what type of customer they were, how they use electricity, how many vacations they typically go on in a year. So a lot of interesting insights once we built the machine learning model and enriched the data set. And we did this obviously iteratively. And then once we had our discrete profiles of customers in the segments, what we did was we designed a custom survey which mapped the responses to the survey to the discrete profiles, and that really helped solve the problem of not knowing if the customer was a good fit for our portfolio before they signed up, because I think that's one of the key problems in this industry is after they become a customer, we can get a good deal of information about them, their historical usage, their historical patterns. But before they're a customer, it's not only risky for the company to sign them up without much prior knowledge. So this solution really helped address that main challenge of we simply don't know much about our customers, but with the help of machine learning and the custom design survey, we were able to upfront a lot of that uncertainty. Secondly, once we had the capability to identify good from bad customers from our existing portfolio, the next step was really let's think about how to better understand them so that we can offer them a better product, better rates, not only for them or really for us. And we even talked about from a negative margin perspective, we could, because we have their historical usage data, we could find a better deal for them, even if it's not within our product offering. And in order to do that, the backbone of this exercise is building a robust demand forecasting model. And I think this is a classic story you'll hear about ML. And what we've done was, I think within 4 to 8 weeks, we were able to stand up a demand forecasting model based on our historical usage that we've built automated data pipelines around our existing customer base. I think I want to say within a month or two, we had about 8 terabytes of data with varying different intervals from hourly, monthly, weekly, 15-minute interval data about our customers. And we infused that with hyper-local weather data. So because we had their address and we had a subscription to a weather forecasting service, we were able to build much better demand forecasting models for our individual customers very quickly. I think within 2 to 3 months, we were able to compare our demand forecasting results to a service that the company was paying for, I think $50,000 annually. And our results were comparable, not better. And that was only with three months worth of work. And that demand forecasting model was really the backbone of our work. If we were able to forecast and understand historical usage, then leveraging what I mentioned earlier, if we can profile our customers into discrete segments, we can then better understand what products and services will be better suited for them. And I think the last point on this slide is talking about one of the main challenges I think in this industry is the electricity usage data. It comes in retroactively, so it's at best a day behind. And because you don't have real-time or daily usage for a lot of our customers, a lot of retail energy providers struggled with creating better forecasts. And one of the ways we went about that was we got better or more updated weather forecasts throughout the day. So we built our models in a way that it would update to the interval of how quickly our weather data was coming in. So we were generating new and updated demand forecasts within the day. And that led to a lot of the close to real-time offerings that I'll talk about in upcoming slides. So this next slide is talking about customer retention, so more targeted around Alex. How can we build machine learning models to better to predict and find out which customers are at risk of leaving, and if they are good customers, we want to take action on them, obviously before their contract expires, and they might jump ship. So for this one, we leveraged our existing demand forecasting models already, but we took a more customer-centric approach. We enriched our data sets with customer interactions. So how often were they logging onto our website? Do they have our mobile app downloaded? How often were they using our mobile app? How much time were they spending on our mobile app? How often were they paying their bills? And I think the interesting find there was actually, in one of our models, we found out that customers that paid their bills late were actually more likely to stay with us as a customer. So that was a very interesting insight that we got from our machine learning model, and the customer retention team was very happy to hear just some new ideas and different than the ways that they've been thinking about this problem. All right. And next is really just a quick blurb about how simple and how quickly we were able to develop this customer churn model in AWS. So the three AWS logos in the middle are really what powers most of our machine learning solutions. So AWS Lambda was able to quickly pull in and transform and clean and shape the data from our customers, like I mentioned, their customer usage, their historical billing history, and customer interactions like websites, bill payments, and other interactions they have with us through our different channels. And then S3 is able to quickly and cheaply store and help us access information. And the key here is Amazon SageMaker is a great platform to build the machine learning models and really help us derive value from all the data that we've stored. And the way that the solution worked was, as new data points come in, let's say they logged into the website, that would get fed into the machine learning API. And based on that new data point, it was able to produce a number, right, a percentage of how likely was this customer going to renew with us, and if that number was below the threshold, it would get pushed to the customer retention team, and they would take action, whether it's a call or just email campaigns. And I think from this campaign, we were able to help improve retention rates by 10% just by proactively sharing the list of customers that were at risk of churning before their contracts were up. Next, let's move on to the diversified products portion. I think this is where a lot of the exciting and game-changing ideas have really fallen. So once we've identified good from bad customers, once we have started to better understand our customers, how can we optimize, actually this one is, how do we understand our competitors better? So from a smarter pricing strategy perspective, how do we better position our products and our prices in the marketplace? This one we thought was pretty novel, just because especially in Texas, all of the rates are public from all of our competitors. So we simply built a web scraping service that would go out to the publicly available data, and we pulled all of the historical plans and offers across, actually not only in Texas, across all of our operating markets, and we stored them in AWS, and we were able to quickly create machine learning models to just simply predict, based on historical prices, what is competitor A, B, or C likely going to set their prices for the upcoming month. And as time went on, we actually enriched this data set with additional data, related data, environmental data, such as the price of oil, price of the cost to buy and sell electricity for that region. And we were able to help the pricing team better position. Like, hey, we know that this historically this competitor is likely to price at this rate given these conditions. We could better adjust. We can better adjust our strategy and decide whether we want to compete with them in that area at that time. After that, thinking about from the external perspective, if we take a look internally, how do we optimize our margins for our existing customers? And I mentioned this earlier. This is really the beginning of how do we better serve our customers so that we are offering them ancillary services that are not only beneficial but valuable to them and to us. So the challenge here was really thinking about how do we design the right products for each individual customers. And I think the good news is, as I mentioned before, we've already had machine learning models that were tailored specifically to each premise or each customer. So we were already producing demand forecasts at the premise level and the meter level. So we had a really fine-grained view and understanding of each and every one of our customers. So the idea here and the power of this one was we've actually helped build a custom pricing and costing engine, which really is to say we store all the different formulas and the way they looked at costing and pricing energy. So we were dealing with a variety of different markets and different slices of electricity data. So the engine was able to handle 15-minute interval data, hourly data, monthly, you name it. And with the combination of the different electricity usage profiles and the combination of the various different equations for costing and pricing, we were able to build a machine learning model to iterate and optimize what is the best product. And you can you can define best in multiple ways, right? How do we get the best margin for us? Or also you can say, how do we provide the lowest rate for our customers? Or if it's not lowest rate, how can we provide them the best product? And you see a lot of the night and weekends, free nights and weekends, however you want to customize your products and offerings with that level of fine-tuned granularity and predictions. We were able to really custom tailor our products and start having the conversations of we can really move into more innovative and different product strategies. And this particular use case actually lends itself really well into what Chris mentioned earlier, their new AWS's new offering around reinforcement learning. So this shifts the focus a little bit away from just predictions, right? It's not saying, hey, what is the customer likely to accept this product or rate? This is more kind of think about game theory and how do we best optimize through a series of simulations. And like I mentioned earlier, the challenge here is how do we find the best product for the company, and how do we find the best product for the customer? And ideally, that question should arrive at the same product or service. But the idea here is with using reinforcement learning, if we plug in the different equations and the different demand profiles and different maybe low and best estimations, or really low and best predictions for maybe based on weather for the future, we can then ask the reinforcement model to basically go through these millions of different permutations to figure out which one is the most optimal product or plan. And when I say product or plan, they're not slotting or suggesting existing products and offerings the company has in their portfolio today. We're playing at the calculation and equations level. So this solution would actually create and produce net new combinations that would be ideal for again, like I said, both the company and the customer. And lastly, this slide I think is really the catch-all of knowing what we know now with machine learning and all of the different models that we've built, how do we combine them and think about new products and new services that we can put onto the marketplace? And one of the first POCs that we did was we actually built a battery controller and optimizer for a large facility out in New York. It was actually a very interesting technical solution. We had a small, think Raspberry Pi microcomputer sitting out at the battery out there in the facility that had to be able to work offline because the connection, the 3G connection in that facility was going to be spotty. So we had to design a solution that was not only able to run those machine learning models really offline. It would talk to the kind of the main AWS mothership, if you will, to get updates and better forecasts when it's able to leverage the larger compute power in the cloud. And the way that battery worked was really up in New York. There's a peak PLC, a peak load capacity that for the highest point in the year is what makes up, I think, 10 to 20% of a given customer's bill for that year in the commercial space. So if we were able to predict when that peak was happening, we can actually discharge or discharge the battery at that point in time to help really put a dent in that 10 to 20% percent of that customer's bill for that year. So it was really a very interesting and rewarding solution to work on. And with that knowledge and solution around battery, we also thought about how do we get into the solar panel offering services as well. So like I mentioned earlier, we looked at getting some solar radiance data from Google that gave us how much square footage the roof of our individual customers had. And like I mentioned, if we have their demand forecasted accurately, we can actually plug in, and we built calculators for this, we can plug in and calculate the value and the savings each individual customers would get if they were to install a solar panel on their house. And that helped really narrow down our target customers list to target for our new solar panel offering. Next is actually a really interesting, and I'm sure this story has been making its rounds around the industry as well. Is the idea of energy disaggregation, and this is really powered by machine learning as well. Is being able to see just from a electricity profile, being able to break that down further by appliances. So having the ability to predict and say, hey, out of your total usage, 70% of that is actually to your air conditioning unit, 10% of that is your refrigerator, 5% of that is your lighting around your house. That alone gives us a really, really good opportunity to fine tune and tailor our messages and our customer engagements better. We were able to send them, hey, we noticed that your AC was running for 4 hours, but your internal temperature wasn't actually dropping. We think that your AC is malfunctioning, or it's not working as intended. Let us send a AC repair technician out there to take a look and see if we can help. And like I mentioned earlier too, we were able to think about how to package our offerings around smart home products. So thinking about how we can get more efficient lighting based on the energy disaggregation profile. So hey, these smart lights, we can help you program them to turn off when you're not at home, so that you're not wasting 20% of your energy which you spend monthly on your lights when your IoT sensor at home tells us that you're not away. So really shaping that smart home offering and helping our customers understand that we're more than just keeping the lights on. We can actually help them. We can actually help you turn them off when you don't need them, and thinking about you as the customer and not just you as how much electricity you're going to use for the next month. And then the last bit, I think I already mentioned, the Internet of Things is to enable energy arbitrage. My example about the battery example up in New York was a good one, not only in helping shave that peak load contribution peak in the winter, but really the interesting thing was thinking about what time to best charge and discharge the battery, so that we're not only keeping our batteries fully charged at all times, just the time for this one event. We're actually looking at their real-time usage, and as that data is coming in and as the day is progressing, we were sending out signals for the battery to say, hey, this is a good opportunity for us to use the battery because we don't think the peak is going to happen in the next 4 to 5 hours. And you can translate that into the residential area as well, to think about if we had enough smart thermostats, if we had enough control over the smart home devices in our customers' houses, we can play a significant role in demand response. If we know that there's going to be significant demand coming in, because it's a particularly hot summer at 1 p.m., we can actually suggest to the customer, hey, because we have the ability to help you turn on and off your appliances in your home, if you turn off X, Y, and Z appliances, you can actually save $5 on your next bill. And it's the combination of knowing all of those things and having access, obviously, because we're their electricity provider, having access to the billing and rate data, we're able to offer a comprehensive product and service around them, the customer. We're able to have meaningful and valuable customer engagement messages like, hey, we can save you $5 if you take these actions. And better yet, we can do it for you if you allow us to take this action. So really, really paving the way for the future, kind of the smart home. I always like to imagine kind of an Iron Man, Jarvis is that vision of where we're going with the smart home, telling us the insights of, hey, it's gonna rain today. We should lower the blinds or whatever. It's tapping into that intimate customer engagement model into the energy space, which I think is really, really powerful, because as competitive and as difficult as it is to compete in this sector, machine learning and really the technologies have really helped us branch out and elevate our offerings beyond just a bill that shows up every month. With that said, I want to take a pause just to make sure we leave a little bit of time for any questions or details around any of the examples I shared earlier before I jump on to how can you get started and how can we help you, the combo of Pariveda and AWS.
Alex, we do have a question. I think it's a perfect segue actually to your next section. You had talked about, in a previous example, you talked about enriching a data set. So it sounds like you started the process with one data set, you deployed it, you started running some inference, you got some feedback, and then you enriched the data set. So I wonder if you could talk just for a moment about retraining, how important retraining is and how important it is to understand that inference it's a process. You very, very rarely will you take a single data set, train a model, put it in production, and get an accuracy that makes everybody happy and revolutionizes the process. So I guess so two points. Can you talk about the importance of retraining and the importance of taking an iterative approach to your achieving accuracy goals?
Absolutely. I think that is a great segue. So appreciate that question. The concept of retraining is paramount, like you said. The probably the toughest challenge on this machine learning journey, for the last I would say 3 to 4 years, is helping our clients understand that it is a journey and it is an iterative approach. Because at the end of the day, a machine learning model is really just a prediction. And like you said, our goal is to get better and better at predicting. And the way to do that is not to only maybe hire a bunch of data scientists to fine tune and find the best algorithm to increase that accuracy, but it's really thinking outside the box. I think that's where it makes us very good partners, is that we leverage our experience and our partnerships, especially in other industries as well, on what types of data, whether it sounds related or not, will help us get a better prediction or a better answer to what we're looking for. And I think that is really the key to machine learning is really the power of machine learning is that a human would maybe struggle with finding the relationships or finding the correlation between seemingly unrelated data, maybe like I said, maybe the number of windows or the number of bathrooms in a home. How does, if you just threw that out there, it may sound absurd, and it would take a person a long time to build a model and plug that into a spreadsheet and find the correlation of the number of bathrooms to how a customer will use electricity. But a machine learning model in AWS platform makes that task trivial. Right? It's as easy as gathering that data and plugging it in, and then within seconds, really not minutes, you're able to see, oh hey, this number, this piece of information has little or no correlation. Awesome, let's move on. So thanks for bringing up that question. I think that's a really important point to remember and bring forward to my next section, which is really how can we get started? All those examples sounded really good, but what can we do to not only get started on this machine learning journey? If you've already started, you might fall into one of these, probably in the earlier left-hand side of the spectrum of how ready are we at leveraging the data services and realizing value from it. So earlier on, I think I've seen a lot of companies are in the stage of forming, right? Just thinking about, hey, AWS, we have a subscription, we have access to it. It's really, really easy to spin up new models. So they're already creating proof of concepts and just playing around. And like I mentioned, I think a lot of companies have played around with the idea of, can we create a better demand forecasting model so that we can stop relying on some of these expensive services that we're paying for. So that's a very good candidate to get started. And then as you progress throughout this journey and this readiness, we've seen this journey, and we've also seen a lot of misconceptions or really misunderstandings of what is really required to gain proficiency in realizing value. So what we've seen from a structure perspective, the next steps are really getting more educating the business around the value of machine learning. So like Chris was mentioning, how do we make sure that the business is not expecting a one and done, hey, we've built a machine learning model, great, we've solved the problem, we can now do X, Y, and Z. It really is about educating and aligning everybody that it's going to be an iterative model, but here are all the different values and the different services that we're trying to target and go after. And then as you move to the right, it's really about productionalizing and formalizing your organization and structure around how do we crank out these new solutions much more efficiently, more effectively, and more structuredly, so that we have a data lake, a data governance platform that's going to make the creation of these machine learning backlog items a much smoother and much more machine factory-like process. And like I alluded to earlier in the previous slide, we've seen a lot of what we call perceived challenges, or maybe even a stronger word is misconceptions about how do we get started on this predictive analytics and machine learning journey. And a lot of stories that we run into are, I have a really good idea, but I don't know how to convince or articulate the value to the rest of my organization. The other things that we've heard is, oh, our organization is not ready. We don't have the data scientists. We don't have the knowledge. We don't have the technology expertise around how to use it. We're just not ready. And on the right side, we've heard ideas about, oh, it's going to be too expensive. We don't have the time or the money to spend on these complex algorithms and these data scientists to give us these powerful formulas. And I think if you listen to Chris's quick lightning round of all the services, I think that's the biggest misconception we can throw out the window right now, is that AWS has made it not only easy to get started and quickly get started. You actually don't need a bunch of really expensive data scientists up front, because we believe that in the beginning of the journey, it's not as important to focus on accuracy and focus on the complexity of the algorithm more so than focusing on the value and the value of the offerings and the idea. And lastly, it takes too long. Like I said, I think AWS and Pariveda are great partners in that it absolutely does not take very long to realize value. And with our approach, we absolutely don't think it's going to take long to see benefits and values quickly. So our Pariveda framework is heavily tied into the idea of quickly prototyping will lead to answers and value early and often. So the idea is to really try and fail fast, and then failure is actually a really good outcome, because it allows us to pivot and change course quickly, so that we're not spending months and years on a machine learning engagement only to find out, year two, that hey, it actually doesn't do what we were hoping for 2 years too late. So there's this whole concept of identifying opportunities, quickly prototyping and experimenting and learning on the AWS platform, and tying that back and organizing this exercise with the idea of concept cards has really helped a lot of our clients think through and really quickly jump in and really optimize their progression through the journey as well. And this slide is really giving a high-level overview of what that value proposition design process looks like. So it's a 5-stage process that goes from top to bottom. The process is really thinking about how do we take a new idea and funnel it down through the use of prototypes and learning and trying early and often, take in a new idea and refine it into a valuable idea. So and on the left side, you'll kind of see the logos and the idea of a concept card. So in the beginning, you might have a blank concept card because you're still ideating. You're thinking about what are some potential ideas to help elevate our business. And then as you move down through this journey, this review and prioritize, as you fill out this concept card and you socialize it with others, and you get buy-in, you're able to refine and hone your concept card. So you start filling in more details, or you start flushing it out. So you can see kind of the concept card growing over time. And once the organizations have rallied around or agreed on several concept cards, we move on to the research and prototype phase. So let's build it out. Let's make sure that it's a feasible idea, that from a technology, organization, people standpoint, that our company is feasibly able to produce and support this product or offering. And then you move on to obviously research, market test, and deployment. After you've validated that it's a feasible idea, let's make sure that it's a viable idea, that there's a value, the value proposition stands with our customers, and they actually want and like this new idea. And obviously, once you've taken your lessons learned from your market test, you move on to release, and then it's really your realization of this was a valuable idea that's generating value for the enterprise. And here is really just a quick example of a concept card. It's just a really good structure and communication tool to succinctly describe what that idea or the concept is. And this really helps demystify some of the maybe misunderstanding or confusion around machine learning or even technologies alone. And if you look at the bottom right, there's a capabilities section that really helps align everybody on what is missing, what is needed, right? Thinking about machine learning is a capability, right? Data platform is a capability. And I think having that capability section on the bottom, it articulates what we have today, what we need to really fulfill just this concept card. So this concept card helps us focus our ideas on concrete and tangible prototypes to go after. And it helps us pinpoint just the capabilities and just the data that we need. So it's really addressing the top right corner of too costly, it takes too much time. We don't have the people, we don't have the skills, we don't know how to get started, right? These concept cards, and Pariveda, we've run a series of workshops with our clients, whether it's before they've gotten started or even after they've gotten started, to help them organize and think through how to best prioritize the portfolio of these new machine learning ideas that they have ongoing, if not already started. So really, just to wrap up pretty quickly here, this is how we can help you alleviate or solve those pain points of not knowing how to get started on, not knowing how to improve your machine learning capability that you may have today. So the concept cards helps you articulate value because it's a very organized approach to, and then really a solution-based approach to articulate the value. And we don't tend to focus on, we need to build a machine learning algorithm X, Y, or Z. It's really, at the end of it, what are we really trying to solve? And thinking about how technology can solve or enable those ideas as a secondary concept. And then, like I think I already mentioned, the organization not ready. The concept cards will illuminate what capabilities we need to get alignment on, and having a card that you can pass around and share with folks in the organization really helps drive alignment so that everybody is on the same page about what it is we're trying to do and the value that that thing is what we're going after. So with that said, I think we're right on time. So I'll pause here and just kind of say, with the combination of Pariveda and AWS's SageMaker platform, our concept cards, our Agile ML methodology, and the Data Forge pattern for our data platform, we have all the tools to really help you get started on your machine learning journey, really no matter where you are on that continuum. So with that said, that's really all I had for the presentation. I want to open it up for any questions, comments from the group.
Okay, Alex, thank you so much. We're actually at time, so I think what we're going to have to do is we're going to distribute this webinar via a recording. So if there are follow-up questions, or if we did not get to your question today, please feel free to respond to that. My email address will be in that email. This is Chris Burns again. So please feel free to send that question in. And I want to say thanks again to Alex. Thanks again to the listeners. This was a fantastic presentation. I really hope you took away from this some of the context that they outlined. Pariveda is certainly a thought leader in this space, outlining the fact that it's an iterative approach, highlighting on the fact that automated pipelines where you lead into traditional CI/CD processes are just as important as the accuracy of the model. And I really love the use case where you've taken from the world of manufacturing, in this case, power utilization, and brought it into the home, where you've taken machine learning and actually saved customers money. It's a tangible result they can see from all the AI hype that we're hearing about. So with that, we'll close. Thanks again to Alex, and thanks again to everybody that attended today.
Great. Thanks, everybody.